So now in this video we're going to see another example of nodal analysis when there is a supernode. So in this video we're going to determine V1, V2 and V3 because there are supernodes. This one is a supernode. We already discussed about the previous video. So now since it is a supernode, when we are going to draw the same circuit, we will draw by removing the supernode. How? Our circuit now is going to be this one. If we check, we see also this one is a supernode again, because there is voltage source here. There is also a voltage source here, dependent, this and independent, but both there is no any element. So supernode here, supernode. So I will have my circuit will be in this form. I will have my V1 here. I already removed this one. I will have a resistor here. I remove this one. My circuit is going to be this one. So now I have 2 ampere here. I have 4, 2 ohm, and I have 3, and I have 6 here. Now I have V2 here. I have V3 here. Because here I remove the circuit, I remove the supernode here. So the first equation that we are going to see in this supernode, which has the source, supernode 1, 2. In supernode 1, 2, this voltage, because in general, if I have this one, as we see in the previous one, I have 25, in that VA minus VB equal 25. So in this case, I will have V1 minus V1 in this point minus V2 is going to be equal 25. 25, the first equation that I will have. Now in supernode, in this supernode 1 and 2, I have to check using Cassel. I'm going to use Cassel. In this one, this current is leaving. I have another current here, and I have another current here. Now I will consider this one I. This one is going to be I1. This one is going to be I2. The direction doesn't matter. If we put direction here, you put direction here, is not matter. The only thing to follow the voltage when you are the currents flowing from here to here to start this voltage. When you consider that the current is flowing from here to here, you will start V3 minus V1. So now in this current I have in this node, what are the currents entering? This current is leaving, this current is leaving, this current is leaving. In this node 1 and 2, in this supernode, mean that all the currents are leaving. Mean that I will have I plus I1 plus I1 I plus I1 plus I2 plus I2 going to be equal 0. Equal 0. Since there is no current which is entering, and this cannot be true. Some currents will be enter, some currents will be leave. So maybe we will get a negative current. If we get negative currents, don't be afraid. It's among the procedure. Equal 0. Now I, what to determine the value of I? To determine this value of I have V1 minus 0 divided by 2. So I will directly have V1 divided by 2 plus I1. This I1 is coming from V1 to V3. So I will have plus V1 minus V3 divided by 6. 6 plus I2. I2 is this current is leaving. Current is leaving here. I2 equal V2 minus 0. So plus V2 divided by 4 equal 0. Equal 0 Now I have 2 multiplied by 6 is going to be 12. 12. So I will have 12 divided by 2 here. 2 multiplied by 6, I don't need to take this 4 because 2 multiplied by 6 is the common multiple between those. So I will have 12 divided by 2 is going to be 6v1. 12 by 2 plus 2 by 6 is going to be 2v here in I1. 2v1, this v1 minus 2v3 plus 12 divided by 4 is going to be 4, is going to be 3. So we'll have 3v2 3v2 equal 0, equal 0. Now let's see. I will have, there is no another v1 here. I will have 6v1 6v1 plus 2v1 is going to be 8. I will have 8v1. I have plus 3v2 because there is no another v2 plus 3v2 v2. I have minus 2v3 equal 0. Now I get this equation. Now I have to see again. There was a supernode here. This supernode that I remove. In this supernode, I will have V3 because I will start the positive one, because as I say here, VA minus VB is going to be 25. I start from the positive. But if I start VB minus VA is going to be minus 25 because I will take from the negative. Now I can start from here, V3 if I want to keep the positivity, minus V2 is going to be equal how much? 5i because it is a dependent source. Now I have to check how can I replace the value of I. The value of I is this value, which is equal V1 divided by 2. So I'll have V3 minus V2 equal 5i. The value of I, which is V1 minus divided by 2, is going to be V1 divided by 2. Now by the end I will find V3. If it's going to be 5 by 2, I multiply by 2 all. I will have these 2 and 2 remove. I will have 5 V1. I multiply by 2 here and 2 here. They are coming here plus 2 V2. This negative will come in this side. Is going to be 2 V2. This 2 V3 is going to be this side, is going to be minus 2 V3. Minus 2 V3 equal 0. Equal 0. Now let's see another equation. This equation again. Now I have to come in the supernode of node 2 and 3. Node 2 of node 2 and 3. Node 2 and 3. This one 2 and 3 here. Now in this supernode, this current here is entering in this node. There is no other current entering. This current is leaving, this current is leaving. The current come here entering, the current is leaving, this current is leaving. Because we'll take both node. The current summation of the current entering this node plus the current of entering this node equal the current summation of the current leaving here and the current leaving here. In this node, I have only this current was entering here. but there is no current entering here. So I will have only this I1. I will have only I1 equal this I2 plus I3 equal equal. I will have equal this I2 plus I3. The value of I3 is this one because it's living in both nodes. So I will have I2 plus I3 plus I3 here plus I3 here. This current is going to be equal this I3. If I check now I1, now if I check this I1 is what? Is V1 minus V3. I2 is V2 and divided by 4. This I3 equal V3 divided by 3. I can form the third equation again. And if I form the third equation, I have three equations. This one, and the third one. I can directly determine the value of V1 and V2. Now, I have I1, which is equal to V1 minus V3 divided by 6. I have I2, which is equal V2 minus 0 divided by 4. I have I3, which is equal V3 divided by 3. I will form the equation again. And to have these three equations, I can determine the value of V1 and the value of V2 and the value of V3. So that is for this example. Let's say, for example, another example. But what I was discussing is like when we have, let's say that we have a supernode here plus negative, and then we have a let's say V1, V2, and then we have this resistor that is parallel with this one. And that if I'm going to remove this node in this supernode, I will also remove this resistor, which is parallel. So I will have, is going to be remove this one also, in this part also. This one, I cannot say that I have current here. This also part will be removed. Why? Because it is in parallel with the source. Now, another example of this one. In this one, we have to be careful because this one is not a supernode. Why? Because there is element. There is element here, so it cannot be a supernode. Secondly, because it's connected with no reference with a reference. No. And we say that a supernode have to be connected with two no reference node. So I cannot say this one is a supernode, this one is no supernode. So how can I solve it? I have to draw the circuit by removing this, remove again this supernode. If I remove this supernode, I will have current here. You can assume by your own. You have current here, the direction. You have current here. You have also current here. Let's say, for example, if I don't know the direction, don't worry. You can assume any direction you want. If I assume this one is leaving, this one is leaving, this one also is leaving, this one also is leaving. So mean that summation of the currents equals 0. So it's no problem. Someone else can assume this one is entering, this one is leaving, this one is leaving, this one is leaving. It's no problem. Just to follow the node analysis. We assume that this one is leaving, this one is leaving, this one is leaving, this one is leaving. So I will have, let's say for example, this one I1, I2 here, and I have I3 here. I have I. So I'll have I1 plus I2 plus I3 plus I equals 0. Because I don't know the direction, exact direction, the direction is not given me. I can assume both all of them that are leaving equal 0. By the end, I will find one current is negative, mean that the direction have to be changed. That's the general one. So I will see. Let's analyze again. I1. How to determine the value of I1? I1 mean that I have V. I have this voltage V. V is the potential of this one, because this V equal V1 minus 0. It will be V. So I can note this potential here, this voltage here at V. So we'll have I1 is going to be V minus. Now, since the resource here, I will take V minus 14. 14 divided by 4 plus I2. The value of I2 is this one. This one is going to be V divided by 3. No need to put minus 0. This is the value of V. Why I put V? Even this V is the voltage across this resistor, but is the same as the V, as this V. Because here is 0, the reference is 0. Plus I3. I3 is this one, equal what? Here, this now, I can make as V1 here. Plus V1 divided by 6 plus I. What's the value of I? The value of I is this one. It's going to be V1 also divided by 2. Plus V1 divided by 2 equal 0. Equal 0. Now, in this one, you will form one equation. Now, if I already form one equation, I have to find the second equation. I will come in the supernode, in this source. I can start from the positive one. I will have V1 minus this potential V is going to be equal 6. I will have the second equation. And you solve these two equations, you get the value of V, you get the value of V1. And then you told you to find the value of V, this V. This is another example. I hope everyone understand. Next, we'll discuss about mesh analysis. Thank you.